Our Geometry 3.3, the slope of lines, objective. Students will be able to relate slopes with parallel and perpendicular lines and graph lines given their equations. Okay, so slope formula is y2 minus y1 over x2 minus x1. And if you think about it, that makes sense because we learned our whole life that slope is rise over run, or at least as long as we've been talking about slope. And y, when you're looking at a graph, isn't the y coordinates what have to do with the rise, and the x coordinates what have to do with the run? So what we're saying here is how far up does it go, how far over does it go? So if we got 2 points, there's 2 ways for us to calculate the slope. I'm going to show you both. First of all, I'd get in the habit of labeling your points, x1, y1, x2, y2. If you get stuck, it's probably because you didn't label them. And let's just plug it in, right? So I know it's going to be y2, which in this situation is 2, minus y1, which is negative 2, x2, which is negative 1, minus x1, which is negative 3. And anytime you have a double negative, it just becomes a positive. So you got 2 plus 2 over 3 and negative 1, which is positive 2. 4 divided by 2 is 2. So that's my slope. Okay, the other way you can do this is you can plot these points. So let's plot negative 3, negative 2. That's that one. And what was the other point? Negative 1, 2. Negative 1, positive 2. So, and now we can just ask ourselves, well, how far up did it go and how far over? Well, it looked like it went up 4 and over 2 in a positive direction. And so if we were to talk about that is my rise and that is my run. So I could say that my slope is rise over run, so 4 over 2, which is, of course, 2. And what if I went from the other point? I could go down and then back. Well, that would be going down 4 and back 2. Well, that's the same thing, right? Slope is negative 4 divided by negative 2. Negative by a negative is also a positive, so that's also 2. So no matter how we do it, we get 2 for an answer. So that's 2 different ways to find slope. You can do it whatever way you want. I'm going to primarily just do this real quick. But if you're more comfortable graphing it and counting, you can do that too. You just got to make sure you make an accurate graph, and sometimes it's not the most practical way, but if you're graphing, it can be really helpful. Okay, so I want you guys to find the slope of these 2 points. You can do it either way, but just go ahead and try it real quick, and I'll put the answer up in a second. Make sure you know how to find slope on your own. Okay, so I wrote out the equation, y2 minus y1, x2 minus x1, did my y's. So negative 1 minus 0, 0 minus negative 4, that turns into a positive 4. So it's negative 1 over positive 4, and there's my slope, negative 1/4. That's all there is to it. All right, let's talk about parallel and perpendicular lines real quick. Whenever we have parallel lines, they're going to have the same slope. They're going to never intersect. And they should have different y-intercepts, meaning they're 2 different lines. They're distinct lines, not the same line. Now, what about perpendicular lines? Well, perpendicular lines have negative reciprocal slopes. So reciprocal, remember, if I had like 3 over 2, the reciprocal is just switching it so that it's 2/3. But one has to be negative and one has to be positive, so you have to make one negative. So if it is negative, when you flip it, you make a positive. If it is positive, when you flip it, you make a negative. And the slopes have a product of negative 1. So if you multiply the products together, it would be negative 1. Check it out. 3 times negative 2 is negative 6, and 2 times 3 is 6. Negative 6 divided by 6 is negative 1. So when you multiply them together, they should end up being negative 1. And something important to know is that horizontal and vertical lines are always perpendicular. Always. Okay, let's go to the next page. Alright, let's say you're given these 2 lines, A, B, and C, D. Actually, they're line segments. These are the coordinates of those segments. And they want us to find the relationship between them. So we're going to have to find the slopes first. The relationship is going to either be parallel, perpendicular, or neither. So let's find the slope of AB. I'm going to zoom in here. So y2 is going to be 7 minus negative 5 over 4 minus negative 2. That turns into a plus, so you get 12 over 6, which is just 2. Okay, so that's the slope of AB. All right, well, let's find the slope of CD now. So we got negative 2 minus 2 over 8 minus 0. Negative 2 is negative 4. 8 minus 0 is 8. Reduce that down to negative 1/2. And so that's the slope there. Okay. So there's your two slopes. Well, 2 is really the same thing if you think about it. 2 is really just like saying 2 over 1. So these two are reciprocals, and this one's negative and this one's positive. So yeah, this is a negative reciprocal. So we could say that they are perpendicular. So we would say that AB is perpendicular to CD. Okay. So I want you guys to try practice number 2 on your own. Find the slope, and then determine the relationship. Are they parallel, perpendicular, or neither? I'll let you guys try it. I'll put the answers up in just a second. Okay, so here's our two slopes. We got 1 over 4 and 4 over 1. Now, a lot of you guys have probably seen that they are reciprocals, but they're both positive. So they are not perpendicular, because remember they have to be negative reciprocals. So they're not perpendicular, and they're also not exactly the same, so they're not parallel. So for this one, they would have no relationship. Or we could say that they are not parallel or perpendicular, because they're not either one. So be on the lookout for that. You're going to find a lot where they're reciprocals, but they're not negative reciprocals, and they're trying to trick you. Okay. This is the last thing I want to talk about, and for whatever reason, this is often hard. I'm going to add a couple little hash marks. I think that this is one of the easiest things you'll ever have to graph, but for whatever reason, students often get kind of hung up with this stuff. But it's really pretty simple. When you're dealing with x equals a constant number, like x equals 5, or y equals a constant, so like y equals 3, you should know a couple things. One, well, let's just show you what the graph looks like first, and then we'll talk about these things. So how would I graph x equals 5? Well, I'm going to go to where x equals 5. Well, 1, 2, 3, 4, and then we'll just say this is 5 right here. Okay? Well, where else is x equal 5? Well, the thing is, isn't this still where x equals 5, and this is 5, and this is 5? All of this is where x equals 5. So that's how I graph it. I just draw a line going straight up and down at x equals 5. I like to say, where else does x equal 5? And it equals 5 in this line, up and down. So if y equals 3, I'm going to just go to where I know y equals 3. That's right here. Well, where else is y equal 3? Well, it equals 3 left to right. And now take a look at this. So for the blue line, x equals 5. Its slope is undefined. That's because, if you're to think about it, what's your rise? What's your run? Well, is it going left or right at all? No, it's not. So you got a 0. So it doesn't even matter what your rise is. It could be x, it could be anything. You're getting something divided by 0, which is no solution or undefined. That's what we get right there. Okay. What if it's a y equals? Well, what is your rise and what is your run? Well, it's not going up and down at all, so your rise is 0. So it doesn't even matter what your run is, because this is just going to be 0. So that's why you get a slope as 0. Okay. For the summary, I want to know, what is slope? How would you describe it to a 4th grader who has never seen linear equations before? And try to work in, how does it relate to perpendicular and parallel lines? How can you use slope to determine parallel and perpendicular lines? This part might be a little hard to describe to a 4th grader, so if you could just tell me your best explanation of that. But I really want you to try and describe slope in like little kid terms. Okay, see you guys in the next video.